All right, let's take a look at these practice problems to figure out how we can prove that triangles are congruent. All right, so first part here, we want to list the congruent parts. All right, so we know what's given. We've got UF is congruent to CN. All right, that's these two guys here. Okay, and then we've got what else? We have UN congruent to UN. That's the reflexive thing in the middle right here. It's already marked. If it's not marked, we'll get used to marking that. And then we've got the angles. Make sure you use 3 points for these angles when you name them. We've got angle, let's see, angle CNU is congruent to angle FUN. Well, that's fun. All right, that's all that we know. So angle FUN, we got to watch out, get this in order now. F goes with C, so that goes to triangle C. This U here goes with this N over here, so N, and the N in fun, that's this angle right here, matches with this U angle up here, corresponds. And the reason that these triangles are congruent is side angle side. All right. So moving on to the next one here. We've got some congruent parts, just a bunch of sides here. So let's name them just using the marks. Oh, this guy has a little problem here. Let's call this T. We have a missing point there. You can call it another letter, that's fine. Get the same idea. All right, and so we have side TD has a single mark in it, and that's congruent to side PR because it's got a single mark. Then the double mark angles, we have TO, and that is congruent to PE because they both have a double mark. And the triple mark sides here, we got ER and OD. So OD is congruent to ER. And so we've got 3 sides congruent, 3 pairs of sides. And again, this is a little goofed up. We'll just call that TOD. Triangle TOD is congruent to, now let's get this in the right order. T is between the single mark and the double mark side. So R, nope, not R. What's between the single mark and the double mark? The single mark and the double mark makes P. All right, so T is going to go with P. This O is going to go, O is between the double and the triple mark. So double and triple gives you E. Okay, so that goes to E. And angle D. Angle D is between the triple and the single. That goes with the angle R. All right. So the reason that those are congruent are side, side, side. Okay. So next one, we've got some congruent parts here. Right away, when we got this kind of drawing, we want to mark the vertical angles. Always be looking for vertical angles. All right, we had reflexive of above, and here's some vertical angles. So let's name those angles. We've got angle KTI actually is congruent to angle STE. And then we've got angle I. You can use one letter out here because there's only one angle I. That's congruent to angle E. And then we've got the side IT, side IT is congruent to side ET, phone home. All right, so what do we got for our triangles? Now, there is no triangle ABC, so let's just forget that. But we do have a triangle, what do we have? Triangle KIT, triangle KIT. And what is that congruent to? Well, this K corresponds to S over here. So K goes to S, and then I goes to E, and T goes to T. All right? And the reason for that, well, we have two angles and a side that's between them. So that is angle, side, angle. All right? So there's our congruent triangles. And now let's go to the next page and see what else we got. All right, on these first ones here, we want to figure out what else we need in order to use this triangle congruence theorem. We want to use side, side, side. Well, right away we need to mark this reflexive. We don't need to be told that is congruent. We know FH is congruent to FH. If we want SSS, then we need to know that these sides are congruent. We don't know right now, but that's what we would like to know. So we would like to know that BF is congruent to FG. We don't know that, but that's the one thing we would need to get side, 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 and that's what this question is asking. Over here, we want side, angle, side. We know these vertical angles. We should mark them. We want two sides and an angle. Well, we've got these one sides right there. So what we need is I would like to know if this side is congruent to this side. Put a little question mark there. All right, that's what that is, a question mark. Now we don't know that these are congruent. We would like to know them. And we would like to know that SR was congruent to RJ. The moment that we do know that, we have side, angle, side. That's the idea of this problem. All right? So let's go next one here. All right, so Susan's thinking about this drawing here. Susan says that MN is congruent to MN. How does she know that? Well, we know that because of the reflexive property. So you need to be familiar with that name. That's the reflexive property. Looking for reflexive property, we'll be looking for vertical angles, and we'll also be looking for alternate interior angles. Those will show up a lot. Now, Susan says that, hey, that's enough. I know these triangles have to be congruent. Is that so? Why or why not? Well, we've got a side and an angle marked in this triangle, a side and an angle marked in this triangle. Is that enough just to have a side and an angle? No, that's not enough. So, no, we don't have enough information. All right? We need three things, okay? All right, not enough info. All right, that's the idea. All right, on to some proofs here. So we've got a situation here where we want to prove this guy, all right? So let's make a little two-column proof going on here. Okay. Okay. So, all right, we always start with our given stuff, all right? So given stuff, we know that GH is congruent to JK, and we know that GK is congruent to HJ, and our reason is given. Okay, that's the first thing, or things we know. We can group them together. That's cool. All right, the other thing we know is we got our reflexive part right here. We know HK is congruent to HK. Don't forget your bars over this here. Okay, and that is the reflexive property. Okay, and now that's enough. So we can go ahead and say that triangle GHK is congruent to triangle JKH. What's our reason? Side, side, side. So we're doing exactly the same thing that we've been doing in the previous problems, but now we're just getting a little more formal. We've got some statements, we've got some reasons to prove them congruent here, all right? So now we got another one here. Let's see. So we always start out with our given information. So there's our given, that GH is congruent to FM and also GH is parallel. It's useful to mark these things if they're not already marked. So they're parallel, we'll put our little arrows there. Right away, we should notice we've got our reflexive property going on here. HF is congruent to HF. Always looking for that reflexive property because that happens when two triangles share the same side. Okay. And then whenever we have parallel lines, we'll be looking for alternate interior angles. So we have these parallel lines going on here. We've got this line, and there's our transversal. So where's the alternate interior angles? We've got these guys right in here, okay? So we've got some alternate interior angles going on right here and here, okay? So those guys have to be congruent. So we got, let's get the right color. We've got angle, 3 letters now, GHF is congruent to, it's pretty sad, congruence, to MFH, and that is because of alternate interior angles. I'll go ahead and number these. All right? And so now that's enough. We have everything we need. We have a side, we have another side, and we have an angle. All right, and we can see those marked. Those should always be marked there. So we can say that the triangles are congruent. Now notice we were going a little bit further here. GHF is congruent to triangle MFH. Okay, and the reason for that is side angle side. But what were we trying to prove? We were trying to prove that the angles were congruent. Okay, well, we're trying to say that angle G and angle M are congruent. Well, now that we said the triangles are congruent, can we say that that is true? We sure can. Do you remember why? We had that thing that said if the triangles are congruent, then all the parts are congruent. We have a name for it. It's called Cpctc. Corresponding parts of congruent triangles are congruent, all right? So first we prove the triangle's congruent, and then the parts are congruent, and that's what the hint was all about right there, all right? So that's how we prove some triangles congruent and some parts congruent. We got one more on the next page. Let's check it out. Scratch that. We actually have 2 more. One more proof here. We'll start with our given information. Whoops. Get our given down. So we got our given there. Make sure that it's marked, all right? And it's not in this case. So DK is congruent to KJ. Mark them. A lot of people don't mark them, and they get lost, and they don't realize why they're lost. It's because they can't see it. So angle D is congruent to angle J. That's already marked. So we've got these intersecting lines, and so we need to always be looking for vertical angles. And that's all we need there. Angle DKF is congruent to angle JKL. Okay, and that's vertical angles. The vertical angle theorem, technically. All right, so we had 1, we had our given stuff, 2, we've got that. And hey, that's enough. The triangles are congruent, so triangle DFK is congruent to triangle JLK. And the reason is we've got an angle and a side in between. So angle, side, angle. All right. A couple more here. Here we've got some triangle problems with some congruent triangles. So here, what's going on? What happened here? This person said that the 4x plus 6 had to be congruent to this 3x plus 9. Well, what happens? Well, those sides aren't corresponding. So these triangles are congruent. We got a little reflexive going on there, side angle side. But if we're going to do this right, we need to put these 2 together. Those are the corresponding sides. Corresponding parts of congruent triangles are congruent. So let's solve this up. Subtract 4x from both sides. And 6 equals x minus 1. Add 1. And we get 7. All right? That's the idea, okay? Down here on number 10, we got 2 triangles. We know they're congruent. We want to find x and y and then find some missing parts. There, x is a side. Here, x is a side. So what do we know about these 2 sides? They're congruent because QR, look in the drawing here. Not the drawing, actually the congruent statement. And we see over here that QR and DE are in the same spot. So they're equal. So 5y minus 7 equals 38. Okay, add 7. 5y equals 45. Divide by 5. and we get 9. All right? So y is 9, so then the question is, how big is DE? Well, we actually don't need to plug it in. We know DE and Q are the same, so D has to be 38. Okay? Angle S, well, what does angle S correspond to? Well, we look at our congruent statement here. S and F are in the same spot, so S and F have to be the same. Well, how big is F? It doesn't say. Well, we got to figure that out, so let's do that. We know these all add up to 180, so we have 123 plus 29 plus, we'll call it F, equals 180, and so this is 52. Subtract 152, and that F, which we'll call F the size of this angle, would be 28. So this guy's got to be 28 degrees. So we know these are the same. So 2x plus 2 has to be 28. Okay? Subtract 2 from both sides, you get 26, so x is 13. All right? So x is 13, so we know that angle S is 28. We just said that. 28 degrees because S and F are corresponding. All right? And there you have it. There's your review. Also, one more little reminder. Be ready to draw some triangles like a right isosceles. Can you draw a right isosceles triangle? So that would look something, we've got a right angle, and two of them need to be congruent. There it is. Okay. You might need to draw something like a, let's see, an obtuse scalene. Can you draw that? Well, we need an obtuse angle, and we need all sides to be different. So this is obtuse, and it needs to be scalene, so we need to mark them all different. Or could you do an acute? Let's see, acute. How about an acute isosceles? It's acute, so all angles are less than 90. It's isosceles, so that means two sides are congruent. You need to mark those two sides congruent. Okay? And we can do all kinds of combinations of these. Obtuse, isosceles, equilateral. Okay? So be ready to draw some triangles. Know your names, how to name it either by its angles or by its side. Naming by its angles, we can have a right or an obtuse or an acute. By its side, we can have an isosceles, scalene, or also an equilateral, which is not here. So be ready to use those names and make some drawings. Good job. Keep studying, and don't give up. Thanks, guys.